Hi everyone, this is Tom. In this video, I'll show a more realistic demo how multiple customers can engage in real-time chat with one or more customer representatives. In this scenario, customer representatives are automatically notified when a customer initiates a chat session, ensuring prompt engagement. This setup highlights a real-time messaging capabilities where representatives can seamlessly handle conversations with multiple customers while managing notifications and responses in an efficient manner. This video expands on concepts I introduced in my previous video on architecture. If you haven't watched my earlier videos, no worries, you can still follow along. However, I do recommend checking out the group chat video for additional context, since this video, I've chosen a real-world scenario that builds upon that architecture. Some of the previous requirements were keeping all of users' application instances in sync via real-time notifications, sending messages between users and keeping all application instances in sync, storing message history on the server and being able to retrieve them at startup, and enabling group chat messaging and allowing users to join and leave groups. Once I implemented those, I thought about how I could enhance that functionality to enable multiple customer and multiple customer representatives be able to chat on demand. I narrowed it down to 3 requirements worthy of making a demo. I came up with having 2 personas, a customer and a customer support representative or sales representative. Having multiple support specialists join a customer chat and leave as needed. And the key capability of having customer support specialists be notified when a customer starts a chat. One of the key cloud technologies that make it easy to build applications where client and server needs to exchange data in real time is the Azure Web PubSub service. The service facilitates the communication between a publisher and subscribers. That's the name PubSub. In my solution, an ASP.NET Core Web API functions as a central hub, efficiently managing specific communications from clients. Client applications can run on different platforms. The key technology enabling seamless communication on all these environments is the WebSocket protocol. In this case, it provides low latency communication between the client and Azure Web PubSub. Let's go through my high-level architecture. On the right side of my diagram, I have my cloud technologies. I use Azure Web PubSub service that facilitates the communication between a publisher and subscribers, which are my web service and client apps. Below it, I have my web service API that will handle communication requests from application instances and publish notifications to Azure Web PubSub, as well as interact with my database. On the left of the diagram, I show multiple customers running their apps and multiple customer representatives running their applications as well. Customer applications can join a chat and subscribe to various notifications to establish real-time communications. My app checks for any existing active chat sessions and download the message history. At that point, customers can start chatting. The customer representative application starts similarly, but subscribes to more notifications. The app downloads all active customer chats, gets a list of all customer chats that a representative is assigned to, downloads a history of all relevant messages, and then is ready to chat with customers. Let's see how all this works. This is the customer application UI. I'll use Tom as a name for my first fictional customer. Here, I'll see all my chat messages. And this is where I'll type up my messages and send them to support. Status messages section shows some key events from my application, primarily for demo purposes, and to show what's happening under the covers. On the right is the UI seen by a customer representative, in this case named Bob. You see the UI is a bit more complex. Towards the top, Bob will see all customer sessions. Below it, Bob can join or leave any customer session. In a real production UI, I'd make the buttons in line with the chat session. Here will be a list of all chat sessions Bob is active, and the chat messages show all messages from all chats that Bob is part of. Below are controls to send messages to a particular chat session. Again, status messages will show some key events happening in the application. Let me show you when Tom starts a chat. The application subscribes to notifications and tries to download any chat history in case a previous session got disconnected. This is a new session, and thus there are no messages on the server. Let's type a message and send it. My application knows this is a new session and adds Tom to a group named Tom. Then it sends a message to it. In this case, it looks like the UI thread updated the status message with the new chat notification before sending the message to my web service. In my code, the message is obviously sent first, otherwise a notification wouldn't occur. I use a dispatcher queue when notifications arrive to manage execution of UI tasks on the main UI thread. Looks like this time the notification UI update got executed first. In the chat messages section, we see that Tom sees the actual chat message. Now I need to get a customer representative online. Bob clicks the Join Session button and immediately is shown there's a new chat session started by Tom. Bob joins that chat and sees the message Tom sent. In the list of all customer sessions, we see that Bob is now assigned to Tom's chat. I'll have Tom send another message. Bob's application gets that notification and updates the UI. Bob will reply and hopefully help Tom out quickly. A new customer, John, starts his own chat. Once John sends a message, Bob's UI reflects a new customer started a chat. For my demo, I'll get Dave to handle John's chat. Once Dave joins John's chat, all customer sessions get updated both in Dave's and also in Bob's UI. This is all made possible by real-time Azure Web PubSub notifications. Dave sends a message to John. We see the application does that via my web service, and John's app gets the notification and updates its UI. Next, I'll show a scenario where Tom's application somehow got disconnected. Since my application didn't crash, I'll close this instance manually. In the meantime, Bob will send a message to Tom. However, Tom never gets that message, but it is safely stored on the server. Now I'll have Tom start chatting again, and you can see I've restored this active chat by downloading messages from the server, and the chat conversation can continue. Now let's add another customer service manager into the mix named Eric. Eric sees that Bob and Dave are chatting with customers. He decides to join Tom's chat and gets the whole chat history, which he can review. The all customer chat sessions were updated to include Eric. Eric can now chat with Tom. Bob also gets that message. And Tom replies. Since Eric took over the chat with Tom, Bob will leave the chat. In my demo, I decided to clear all chat history once a customer rep leaves the chat. At this point, Bob is not part of any active chat. He decides to join John's chat to help Dave out. That message is sent to John and Dave, and John replies. Dave decides to join Tom's chat and sees that chat history. Now I introduce another customer named Stan. When Stan starts a chat, all customer reps get notified and have the ability to join that chat. Dave decides to join and help Stan. Stan can continue chatting with Dave. We see that Dave has 3 active chats. So Dave will leave Tom's chat since Eric is helping Tom out. That clears out Tom's chat messages in Dave's UI. There are a lot more features that would be helpful in a real-world application, such as customers being notified when a support representative joins or leaves this chat. Showing customers when representatives join or leave their chat was actually very simple to add. I already have endpoints in my web API that handles adding and removing customer representatives from a group chat. All I did was make an additional call to add a new chat group message with customized text. My existing helper managed all the notifications and no client app changes were needed. Here, Tom is a customer and Bob and Eric are customer representatives. Tom joins a chat and sends a message. After Bob joins, his UI shows there's a new chat. Bob joins and sees the same. When Bob joins Tom's chat, a custom message is sent to their common chat. Now Tom is aware that a customer representative joined. The client UI treats this as a group message to display. All the logic happened on the web server. Once Eric joins, that action is reflected in Tom's and Bob's chat messages. Eric gets the full message history and is now ready to receive future message notifications. When Tom sends a message, everyone receives it. Next, I'll show what happens when Eric leaves that chat. Eric's messages are cleared and both Tom and Bob are notified that Eric left that chat. Lastly, I'll show that the join and leave notifications are part of the message history. When Tom starts a new app instance and joins the chat, all messages gets downloaded to the client application. In this video, I showed a realistic scenario how customers can engage in real-time chat with one or more customer representatives using real-time notifications powered by Azure Web PubSub service. Thanks for watching. Hope you found this video helpful.